Okay guys, for the outlier question, the first part is talking about causing the slope of the regression line to be farther from zero, because right now it's decently steep, it's increasing, but farther from zero is another way of saying for this problem, steeper. Because if it's zero, it's horizontal. So if it's further from zero, it's either going to be more steeper not vertically, increasing, or if it would happen to be a negative slope, decreasing, but it's not a negative sloped line. So steeper is what we're looking for. So the two outliers that do that would be the ones at the extreme x values for that. They're going to have the most influence on kind of tipping it up and down. This one causes the line to be kind of tilted upward by including it. It pulls the right hand side up. And likewise, this outlier pulls the left hand side down. So that would cause both of that to make the slope steeper. So the next, it wants to put a square around the three outliers that are increasing the value of s. S, remember, is the standard deviation of the residual. So if you found all the distances of the actual y values to the regression equation line vertically, so all these distances, I want to make that distance bigger. And if we are increasing the value, if we want a bigger s, then I'm talking about the three outliers that are basically the furthest away vertically. So I would say this one is pretty darn far away. Ooh, that's not what I meant to do. This one's pretty far away, as is, I'd say, probably this one. And then it's kind of a toss-up between the two that are already circled in orange, but I'd say this one's probably got a larger residual. It seems to me to be further above than the other one is below the line. So those seem to be causing s to increase because they are the biggest residuals. And then lastly, we are supposed to be placing a triangle around two outliers that are causing the y-intercept of the regression line to be decreased. So we are making wherever this would end up, it doesn't start at zero, so there's an axis break here, but eventually it's going to be hitting the y-axis. I want to know which of our points are making this location, which is not actually there, but making it lower. So I put two outliers for this. I'd really say there's three, because if you are going to be tilting your line to being steeper, so basically, how do I want to explain this? Here's a y-axis. If I have two dots here, then I'm making this steepness. But if I use the same dot, but then make it steeper and connect these ones, I have decreased my y-intercept. That's basically what I'm saying. So if you're making your slope steeper, you are most likely decreasing the y-intercept. So I'd say both of those are fair, but you could also say that this point, while not an extreme x value, is an extreme y value, and it's kind of taking this entire line and slowly lowering it downward. So I said two, but I'm telling you three. I think those are all fair points. And then lastly, it wants all the points with a negative residual. This is not a residual graph, but residuals, again, are y minus y hat. To be negative, these are the ones where your y values are smaller than what's being predicted. So all of these would have a negative residual. Because they are all below the line of best fit, they would all have a y value that's smaller than what's being predicted.